this is going to be a little bit of a change in pace. What we've talked about so far has really been about biology, and I'm going to switch to the more prosaic world of healthcare, where we're not advancing biology, but figuring out how do we actually get the most out of the biology that we already understand. And the question that keeps getting bandied around over the course of the past year or two is, can we trust artificial intelligence in healthcare? It's inconsistent, it's unreliable, it's potentially biased, and that's entirely the wrong question. If you describe to me an entity that works really hard and really fast, has an enormous wealth of information, but doesn't really know how to apply it in context, what you're describing is a fresh medical school graduate. And we don't ban them, we don't say that we don't want them in healthcare. We have developed a set of regulations and processes so that we can use them effectively and safely in the moment, as well as multi-year long training and validation processes to get them better and better and better in terms of their performance over time. And it's taken us over 100 years or so to develop those, since the era of the Flexner Report, in a time when going to the hospital was slightly safer than playing Russian roulette, but not by much. But that's still people. And I think that what's relevant for us today about artificial intelligence comes from something that's even more recent. So I get the slide? So over the course of the past few decades, we've been working the automotive industry has been working to give more and more autonomy to machines in the area of self-driving cars. It's an area where we're trying to, again, take something that was entirely human-driven and give more and more autonomy to a machine in an area that is life and death critical, very highly regulated, and where there's an enormous amount of deployed capital in society. And the Society of Automotive Engineers figured out we need a framework, and they developed this 5-level framework where level 0 is a World War II Jeep or that 1990 stick-shift Toyota Corolla that I learned how to drive in. It's a machine. There's nothing smart about it. Level 5 is a car with no steering wheel. There's really no role for a human in it. And if we look at where we are today, any new car is going to be level 1 to level 2. Level 3 is starting to roll out, and level 4, we're just seeing it in a couple of spots. It's there, it's real, but it's a tiny, tiny sliver. But there's been a lot of progress here. And I'm going to argue in the next slide that healthcare is exactly the same. That we are transitioning autonomy from this very human area of what was clinician and physician judgment to a machine. And so my colleagues and I have worked out a framework where, level 1, it's back office, no doctors involved, no patients are involved. It is in healthcare, but it's separate from the clinical world. At level 2, we're trying to improve that. We're not trying to change any of the clinical decision making. There's no actual autonomy going into the machine, but we're trying to make the process a lot better, both for the patient and for the clinicians. Once you hit level 3, now we're talking about decision making. We're talking about clinical decision support, where we're trying to use the AI to get the clinician to make their decisions better, faster, do more of the right things, fewer of the wrong things, but the process is transparent and entirely traceable. Level 4 is where it's now black box. You don't know why the machine is saying what it's saying, but we're supposed to trust it. And this is the level where the FDA says you now need to be regulated as a medical device and have a validation level consistent with that. And level 5 is when we're really giving true autonomy to the machine. An algorithm will make a licensed decision about prescribing a test or a medication without a human in the loop. And for the foreseeable future, level 4 is science. Level 5 is science fiction. We don't even have the legal or regulatory mechanisms to know how to deal with that, much less the technology that can be validated for it. And while it's going to seem boring, for the next couple of years, all of the real action is going to be in levels 1 and level 2. This is where we can, generate quick ROI, which even though healthcare organizations take up something like 20% of the GDP, they all feel like they're poor, and so they want their money back really quickly on whatever they invest. But this is also going to teach us how to manage non-deterministic algorithms and regulate these non-deterministic algorithms to be able to perform consistently and reliably in order to have impact. At the same time, what's happening in level 3 and level 4, some of that is happening, but it's going to be really research for this first phase until what we've learned in level 1 and level 2 lets us know how to perform, and it'll be time for the second wave. And we can actually go into really changing decisions at scale in a way that gets physicians to do more of the right things and fewer of the wrong things. And I think this makes intuitive sense for anyone who's experienced healthcare. People aren't dropping dead because their doctors are making really bad decisions, prescribing the wrong medications, misdiagnosing. It happens, but it's not the big problem. The big problem is that people are locked out of care because they can't afford it, because the system doesn't have capacity. We talk about the silver tsunami, and there's going to be this huge shortage of doctors. But we also know that about half of the healthcare that's delivered is either unnecessary at best or actually harmful, and that about half of the time that's spent by all kinds of clinicians is fundamentally administrivia. So already we have a 4x reserve capacity that's just waiting to be unlocked. And I think generative AI is going to be a big part of this story that helps us to unlock that. Thank you.